Hi, everyone. Well, if you have spent some time with Flutter development, chances are you have seen a warning like this before. Here we have a widget with a build method, and it produces a warning because it's missing the override annotation. And you may also have faced, probably ignored, a warning like this after upgrading Flutter in your project. Over time, some API is getting outdated and are marked with the deprecated annotation to make us stop using them. So we are interacting with annotations like override and deprecated quite a lot in our Flutter development. They trigger analyzer warnings and are used by library and frameworks authors to communicate correct ways of using the API. And our bare responsibility as Flutter developers is to comply to those guidelines. However, it will make us even better developers if we learn to apply the same techniques in our own code base. And it doesn't matter how big your project is or how big is the team maintaining it. If you're going to work on it for some substantial amount of time, even if you're a single developer there, annotations can be a great way to provide technical documentation for the code right inside the code base and communicate intention of how it was supposed to be used. Of course, documentation can be written somewhere outside the code base, can list all the best practices, architectural principles, naming conventions, and so on. But it's most efficient when it's built into the code base, issuing analyzer warnings the moment something is off. That's way better than relying on CI checks that are run after the code is written, or to wait for someone to call it out during the PR review, if it ever gets caught at all. So today I'd like to talk all about annotations as a way to guard this quality. But before we continue, in case we haven't met before, I'm Anna. I'm Dart and Flutter GDE from Ukraine. I'm passionate about technical excellence and quality and about sharing my experience at tech conferences, blog posts, and online. I'm currently leading the client platforms team in the UK fintech company called Tide, where we provide financial services for small and medium businesses across the world. And we write our applications with Flutter. So let's first review what built-in annotations are available out of the box, which you can leverage in your code base. And before you think, oh, it's so basic, just give me a couple of minutes, it will get more interesting. I'll start with the most basic and popular one, override. Here we have a classic object-oriented example with animal abstract base class and a method called makeSound. And we have a child class cat that provides an implementation of that makeSound method. And this code generates a warning that the member makeSound overrides an inherited member, but isn't annotated with override. And this will be true for any child class that declares a member with the same name as a base class and does not use override annotation. This is done so that developers either explicitly specify they want to replace the behavior of the base class with this annotation or choose a different method name and not confuse the users. This makes the code base more error-prone. We use the deprecated annotation much less often, but mostly we face the consequences of it being applied in libraries and frameworks that we use. Authors use it to indicate that some API are getting deprecated and will be removed in future versions, so we should stop using them as soon as possible. And we can apply the same principles in our code base. In this example, we have a class dinosaur marked with the deprecated annotation with the explanation extinct reptile. And the makeSound method is annotated with plain deprecated annotation. So below, when we try to instantiate a dinosaur, we see warnings that this code is deprecated and shouldn't be used. Here we have a base class animal marked with immutable annotation. That means every subclass of animal must have only final fields. But in our example, class rabbit has a mutable field name, and thus we get this warning. It is another way for library authors or ourselves, really, to enforce the intended usage of a class and prevent mutability bugs. Here, we have a base class animal with a method eat. It is annotated with must call super, which means that any subclass overriding this method must still call the base implementation. But in our subclass hamster, we have overridden it without calling super. If you check the implementation of the base class, you'll notice that it updates the internal state object, and without calling it, the hamster class implementation is buggy, and it will keep eating and eating forever. So it is nice that animal class authors have a way to configure analyzer with must call super annotation to immediately warn us that we are violating the contract. Now, imagine our animals lived in some kind of environment or habitat. Here we have an abstract class habitat with a list of animals and a class called Earth that implements it. And we have a global final habitat instance. Now, we want the animals list to be up to date with all the animals that get created. And we don't want to pass the habitat instance around in all those animals all the time. So animals instances access it via that global variable and register themselves in the list. This code as it is now is hard to test. We all know that Earth is somewhat unpredictable environment, and in tests we'd like to replace it with something that we can control. In real-world projects, a good example of such an environment will be a file system. But if we made this global variable non-final, it would open the floor for potential bugs. So what we can do instead is to transform it into a getter that would either return a given instance or instantiate the Earth class as a fallback. And we can mark this given instance as visible for testing annotation, so it can only be provided in tests. And if accidentally some production code tries to override this habitat instance, it will produce an analyzer warning. Next, I prepared a few lesser-known annotations just to tickle your curiosity. A use result can be used above a method, getter, or function to force you to use the result it returns. In this example, we have a class called chicken, and we have a destructive method called collect eggs that clears the list before returning. So it would be a real pity to lose all those eggs if the result of this method is not stored, right? But since I applied the use result annotation above collect eggs method, the code below produces a warning that the value should be stored. And there is an annotation called do not store, which has the opposite effect. Imagine there is a getter which is likely to return a different value every time it is called, just because the environment it talks to is very dynamic and it changes quickly. Like, for example, the animal's population size. So we would not want someone to persist this number into a variable and then make decisions based on the local copy, just because it immediately gets outdated. So by annotating this getter with do not store annotation, I can produce a warning when someone saves its value. Well, it's quite a rare case, but still nice to know. So this list is not exhaustive, and you can find even more available annotations in a meta package. It even still contains the required annotation, which we used on named parameters before it became a language keyword. Now, as someone who works in a team with close to 100 Flutter engineers on a project with millions of lines of code, where it is impossible to track all the changes and review every PR. I always look for ways to automate some quality guards and minimize human errors. And in a project of such a scale, there always are some custom agreements that cannot always be fully covered with only built-in annotations. However, you can create custom ones for that. And first, let's explore what annotations really are. Override is just a constant instance of some empty private class. And thus, it offers a single usage, just this constant instance. Deprecated is also a constant class with a single message field. Here we have deprecated with capital letter, which is a class name, and thus a constructor name, and deprecated with small letter, which is an instance of a class. And this here actually is a good example of naming convention for annotations. Class name with capital letter and instance with small letter, really just in any regular Dart code. And this instance can be used directly, just as the override annotation above the make sound method, or we can create different instances using the const constructor, providing a custom message as we have above the dinosaur class itself. The main point is to have a const class constructor and its instances as const, and that's it. Annotations is just a constant. So now let's create our custom annotation and see how it can serve as code documentation. As an example today, I'll be demonstrating an annotation called must-use-const. In sizable projects, we may be relying on tree shaking to exclude some undesired code from the bundle. In this example, dev utils are only initialized for development builds, and we rely on tree shaking to exclude them from production builds. And the tree shaking mechanism relies on constant values to decide about the dead code. It is relatively easy to satisfy such a requirement at first, when you're just developing the new functionality and the condition is straightforward. But over time, conditions may stack up, the code gets moved around, refactored in a hurry probably, and before you know it, const gets replaced with final because of some dynamic condition, and without any warning, development utils leak to production builds, and nobody notices it until a few releases later. And actually, this is a very real issue that happened in our Flutter project. And this is where must-use-const annotation would come in handy. Let's start with this declaration. Here we have a Dart class called must-use-const with a const constructor and const instance of such class. Also notice the target annotation above the class. It indicates what type of code elements can be annotated. In our case, it's a top-level variable. So it will automatically issue a warning if some unexpected code element is annotated instead. And here is an example of how it can be applied. At a very minimum, it reminds developers who come to maintain or refactor this code about the previous agreement and hopefully makes them pause and think that maybe this condition was important and reasons why this annotation was added. However, it would be even cooler if somehow we could automatically make sure that the top-level variable it annotates remains const. Because developers still may forget about the requirements or get inattentive, but analyzer will not. And having a warning like this would definitely have helped us avoid a production issue in our code base back then. In fact, in many cases, annotations have corresponding linter rules. Even override annotation will not give you a warning without annotate overrides rule enabled. So now I'm going to show you one of the ways to create custom code checks. I chose the path of building a custom analyzer plugin because it has the benefit of integrating your custom rules into the standard framework reporting mechanism, which means you get warnings right in your IDE the moment you introduce a problem, and also with the standard Dart analyze command. Here I prepared a very simplified, maybe not the most efficient example of how such a rule could be implemented with custom lint package, just to give you an idea. Here we declare a child of Dart lint rule and describe a warning it will issue. This top-level variable must use const. Then we subscribe to a callback that will be triggered every time the source code we are analyzing contains an annotated element. And inside the handler, we check if the annotated element is a top-level variable, and if it is annotated with our must-use const annotation but is not const, we issue a warning through the reporter. Well, although I make it look simple, the combination of annotations and custom linter rules is a rather advanced topic. But it can bring great benefits when working on the larger code bases, as it provides automated enforcement of best practices and following team-wide agreements, which is sustainable over time. If you're interested in more details of creating custom linter rules, I can recommend to check out this video. The API has changed since the time of recording and will most probably change again pretty soon. So also be sure to check the latest documentation for that. Now, I would also like to point out the role of annotations in code generation. We are all probably used to using JSON serializable package to help us with JSON deserialization of API responses, and are used to writing a code like this. Here, the JSON serializable annotation is a critical part of the implementation, without which the code will not be generated. But also it is a part of the code documentation, thanks to which we can understand what code will be generated without actually reading through it. And now if you look inside the implementation, once again we see a plain Dart class with a const constructor and a few final fields. This time they configure the output code that the generator will produce. And the class is annotated with target kind class type, so this annotation can only be applied to classes. Two conclusions here. First, once certain agreements around how we do JSON deserialization in a particular project are established, we tend to repeat this configuration over and over again. But remembering that annotations are just regular Dart classes that can be instantiated, we can create reusable instances of such annotations and apply them instead of copy-pasting the declaration and achieve exactly the same result. And second conclusion is that we can create custom annotations that will drive custom code generation. Well, in fact, in this context, all of the annotations, including JSON serializable, freezed, injectable, auto-wrote, REST API, all of them are custom. And for this example, I will demonstrate an annotation from my barrel files generator package. Well, without going into the details of the package and the motivation behind it, there is an annotation called included barrel file. It can be applied to all top-level elements like classes, enums, global variables, functions, extensions, and so on. And after the code generation with build runner is executed, those elements will get collected in a single barrel file for this package. And to achieve that, first, I have declared an annotation class and an instance of it. And this, once again, is a very simplified version of the code that collects all code element annotated with this particular annotation. Then it gets the names of those elements and the name of the Dart library they are declared in, and combines them into a single export directive. This is a method that produces the output code. The example is not full from the standpoint of creating the code generating package, but I hope it gives you the idea of how generators can rely on annotations and Analyzer API to parse your input Dart code and produce the generated output. And if you'd like to learn more about creating a code generating package, check out this recording. So, today we have discussed what annotations are, how to create your own custom annotations, and how you can leverage them in your projects. We've seen how they can serve as code documentation, help produce analyzer warnings with custom linter rules, and help configure code generators. And my hope is that after this session, you'll start looking at annotations not as just something we have to occasionally use, but as a tool that you can actively leverage to make your code base more expressive, more maintainable, and reliable. That's it for today. I'll be around after the talk in the Flutter community booth. Thank you.